Okay, today I want us to discuss statistics. Mainly statistics 1, because we cannot exhaust everything. In statistics 1, what are we expected to know? The first thing to know in statistics 1, it is measures of central tendency, which includes the mean, and knowing how to determine the mode, and then knowing how to determine the median. We will do all of this on ungrouped data. Fortunately, this one is what we did in primary. And the extension we have is to do this one on grouped data. On group data, what we are expected to know, number one, is how to develop frequency distribution table. Frequency distribution table for given classes. We should also know how to come up with class limits, and you know the difference between the two, and the class boundaries. Class limits, for example, when we have 1 to 10, and then second class is 11 to 20. These are the class limits. If you check, you can see that this number, this is the lower class limit, and this is the upper class limit. The upper class limit, it is not the same as the lower class limit of the next class. So we have 10, we have 11. There's a difference between the two.
Cha?
Yes?
I'm not seeing a screen.
Let me check. Oh, sorry, I did not share the screen.
Yes.
Now you have it. Eh?
Yes.
Yeah, good. I said we discussed statistics 2. And in statistics 2, we know the mean, mode, and the median for ungrouped data and for grouped data. In grouped data, we need to know how to develop a frequency distribution table from the data that we are given. For us effectively to develop a frequency distribution table, we need to know class limits and the class boundaries. Now we were demonstrating what is a class limit. Class limit, for example, when we have 1 is to 10, and the second class is 11 to 20, these are class limits. These are class limits. Now, this is 1 is the lower class limit of the first class, 10 is the upper class limit of the first class. Second class 11 to, now the third class definitely would be 20 to 30. There is a gap between the the upper class boundary of the previous class and lower class boundary of the next class. So that is 10 and 11. So 11 minus 10, we have 1. We share this one equally, we get 0.5. This 0.5, if we add this 0.5, we subtract the lower class boundary, we get 0.5 to 10.5. Then we get 10.5 to 20.5, 20.5 to 30.5. These are now class boundaries. That's the difference between class limits and the boundaries. For class boundaries, the lower limit of the lower boundary of the next class and the upper class boundary of the first class is the same. So we have 10.5, 10.5, 20.5, 20.5. So these are boundaries when they are the same. Boundaries will help us to come up with the class interval. Class interval is equal to 10.5 minus 0.5, which gives us 10. So class boundaries can help us to get now the class interval comfortably. This is what we want to use to do some calculations. Well, let's go ahead. Now we are done with, I wanted you to know the class boundaries and then how to find the class interval. When time comes, we want to sort that one out. What are we expected to know? We do representation of data. Representation of data. And this one will be done, we measure on two. That is, we discuss mostly the histogram and we discuss histogram and we discuss the frequency polygon. This is what is mostly discussed. But we have other ways of representing data, histogram, line graph, pie charts, and pictograms, and others. But mostly what is examinable and what is tested is histogram and the frequency polygon. Histogram is a graph of frequency. Histogram. Histogram is a graph of frequency against upper class boundaries. But we start from the lower class boundary of the first class. This is when, if the data has uniform class intervals. You have seen what intervals are. Histogram is also a graph of frequency density over upper class boundaries if the interval of classes is non-uniform. We are going to witness that one along the way. So if the interval is non-uniform, it is frequency density against the upper class boundaries. How do you find frequency density? Frequency density is equal to frequency over the class interval. And if we cross multiply, we get that the frequency, it is equal to frequency density times the class interval, which gives us the area of the bar. We are going to discuss more, and sometimes a constant can be introduced. So frequency is equals to Ka, where A is the area of the bar. If we have a bar of this kind, so this is frequency density, this is the interval. So the interval times frequency density, it gives us the area. So that area represents frequency of that given class. Let's move on and see how it's going to behave. Okay. Now, frequency polygon, it is after you have drawn maybe the histogram and it has behaved in this manner. Frequency polygon will be the lines joining, the straight lines joining the midpoints of the midpoints of the bars. That is if you have drawn the histogram. And then we make assumption that there was another class after the last class and a class before the first class with the same frequency, with a frequency of 0 and the same class interval of the. So we join to this one and we join to this. So frequency polygon, it is the graph of frequency density, frequency density against class midpoints. This is what we call frequency polygon. Let us go to questions and see how they will behave. First question. We are going to concentrate on paper 1. Mostly statistics 1, it is in paper 1. So let's focus more on paper 1. Okay. Trial. Let us focus on a question that has maybe 10 marks. Trial 1, paper 1, question 17. Trial 1, paper 1, question 17. Trial 1, paper 1, question 17. Question 17, good. It looks fine. Question 17. Joy, read for us the question. Joy is like not in. Brenda, read the question.
The following are masses of 25 students in Form 4 class. Teacher, hizo masses nizisome ama?
Pana, soma hizo zingine.
Question A, draw a frequency distribution table with the lower class 40 to 43. B, estimate the median class. C, draw a histogram for the data.
Well, so we are given the masses And the first question is to develop a frequency distribution table for the data. I don't know how you do it, but at times we do it mechanically. There's no proper formula for doing the same. So we are told that we start with the class. Sometimes we do tally, and then we do frequency. I'm including this column because sometimes the class must be started. So we are starting from the class of, with the lower class 40 to 43. So we have 40 to 43. So the highest value in this case is tutajua along the way, but I'm saying 59. So we can go from, so we have 43 minus 40 is 3. So our next class would be 44. I want you to note that one, to 47. 44 plus 3, 47. The next class would be 48 to 51. 48 plus 3, 51. Another class would be 52 to 55. Next class is 56 to 59. I don't think whether we have a number which is exceeding 59. 30, I mean, where is 40? We have 49. 49 is between 48 to 51. 51, the same there. 50, Guapo. 60. Oh, we have 60. So we have 60 to 63. 60. So tally, we make the tallies for the numbers. 55, it is here. 45, 56, 51, 58. I think you are following what I'm doing. You put the tally. 59, 50. The last one we cross. That is 5. 62. No, not 62. Not 50. 51. Then if we stop that where?
50.
We have not done 40s. So 50 tumeikosea mahali. We have taken 50, si ndio? So we 58, 59. The 51 we said we do what? We cross. I want you to see the process of doing the tally because it may arise along the way. 59. We have not done 59. 44. 42. I think you are also doing the same so that we compare. 42. 59. 50, 62. 46. 43. 57. 56. 52. 43. 41. 40, you cross, 54, 44. So that's the 30. Then now we launch the frequency. This one is 5, according to what I have. This one is 4. This one is 5. This one is 3. 5 plus 4, 9. And this one is 2. Let me check. If it cannot add up to the sum I want, then you get back and check maybe something left out. But when you are keen, it may not be the case. I'm only showing you the process. 9, 14, 17. Mine has exceeded because they were 25. I will interrupt the case. Mine has exceeded by 3. I will kill these 3 here and remain with the 2 karabati nafanya, but because of time, but you have seen the procedure. So I have 9 plus 5, 14, 17, 23, 25. So the sum of frequency must be 25 to match the one that we have here. That is the frequency distribution table. That's how we develop frequency distribution table from given classes. And at times you are given the starting class. Any question here? So be very keen so that you don't miss out. Next question, estimate the median class, median mass. The median mass, we normally say median, we need cumulative frequency column. For median, quartiles, deciles, percentiles, such, we need frequency, cumulative frequency column, which we do by 5. 5 plus 4, 9. 9 plus 5, 14. 14 plus 3, 17. 17 plus 6, 23. 23 plus 2, 25. The last figure must match the total frequency. So starting from there, to find the median, we use the formula. Median is equals to lower class boundary of the median class plus n over 2 minus c divided by f times the interval. So we need to identify the median class. 25 over 2, 12.5. 12.5 lies in this class. So you circle the median class. That is 25 divided by 2, which gives us 12.5. So the median mass should lie at a position of 12.5. So we get the first number along the cumulative frequency, the first number that will accommodate the 12.5 equal to 12.5, or that can accommodate that is higher than 12.5, so which is 14. So in the cumulative frequency of 14, we circle, and that one gives us our median class. So from the median class, we choose the lower class boundary. Lower class boundary of the median class, which is 47.5 plus n over 2. N over 2 is 12.5 minus cumulative frequency above the median class, 9, over the frequency of the median class, 5, times the interval of the median class, 4. The interval of the median class is 4 because we have 51.5. 51.5 minus 47.5. That's what we agreed how to find the class interval. 47.5 up to 51.5. So 51.5 minus 47.5, which gives us 4. And this one gives us the answer to the median. Draw a histogram to represent this data. Somebody who has worked out? What is the figure? Uh-huh. Are we communicating?
Sasa mimi nimepata 50.3.
50.3. Sawa, na wengine watafute yao waweke hapo. Ndio na hiyo. Just you calculate, you get the answer for the median. So what I want you to know is the formula for the median class, which is a lower class boundary, n over 2 minus c. C is the frequency, cumulative frequency above the median class. F is the frequency of the median class times the interval. Next question. Draw a histogram for the for the data. I want to get back and see how we can draw histogram for this data. For the histogram to kick off, we need another column for class boundaries. What we had are class limits. These are class limits. So we need a class boundary, column for class boundary. And so we need one column for class boundaries. So class boundaries. For class boundaries, our first class boundary is starting from 40 to 43. So 43, difference between 43 and 44 is 1. 44 minus 43 is 1. So we divide by 2, 0.5. So to get lower class boundary, it is 40 minus 0.5, which gives us 39.5. 39.5 to 43.5. Then we have 43.5 to 47.5. Then 47.5 to 51.5. 51.5 to 55.5. 55.5 to 59.5. 59.5 to 63.5. So we need this column for the frequency for the boundaries. Then we make an observation. What do we have? Do we have the same? What are observe the intervals? Then we need another column for the class interval. Class intervals, we do class intervals. 43.5 minus this one, 4. So what do you notice is that the frequency, the class intervals are uniform. So if the class intervals are uniform, they will now inform us that we don't need a column for frequency density. So you must have the sequence, the flow of ideas. One, we want to draw a frequency, a histogram. The first column, the column you need for histogram is class boundaries. List all of the class boundaries. From the class limits, create class boundaries. After class boundaries, come up with a column for class intervals for 3.5 minus 39.5 class intervals. Then observe, are the class intervals uniform or non-uniform? If the class intervals are non-uniform, we need another column for frequency density, where we said frequency density is equal to frequency of the class over the interval. So in this case, we don't need frequency density because the class intervals are uniform. So we go ahead, then we draw our histogram where we have the upper class boundaries. You write in full, and then you say what it stands for. It is the mass of students. Then on the, we have frequency. Frequency on the y-axis. This one, it dictates for frequency because the class intervals are uniform. So we go with frequency against upper class boundaries. So what is the frequency for the first class? Frequencies were somewhere. Acha tu tusiandike vizuri for purposes of not referring so much. The frequency we have is 5. Oh, we have 5, 4, 5, 3, 6, and 2. So we have our frequencies. So the highest frequency is 6. So we need something that will accommodate 6. 1, 2, 3, 4, 5, 6. We start from the lower class boundary of the first class, which is 39.5. It goes to 43.5. Next is 47.5, 51.5, 55.5, 59.5, and 63.5. It may not be very clear, but those are the class, upper class. We start with the lower class boundary of the first class, then we proceed with the upper class boundaries of all other classes. Then we do now plotting. Plotting will be 39.5, 5. We draw this one, and it has given us 30 bar. Next is for 3.5 up to 4, frequency of 4, frequency of 4. We also draw this bar. Next is 51.5, 4. We do 4 and 4. We have this bar. Not 4, it is 5. Sorry. This one has a frequency of 5. So it is 5, 5. And then next has a frequency of 3. So 3, 3, 3. Next has a frequency of 6. So we go to 6, 6. And the last one has a frequency of 2. So we have 2 and 2. Well, then it is recommended that you shade the bars, and that is your frequency, that is your histogram. Then we agreed that from histogram, you can also find the frequency polygon. Frequency polygon, we make the midpoints of all the bars, and then we join using straight lines. So we join this one using a ruler. We join these ones. So this is our frequency polygon, but it must start from the midpoint of a class that is assumed that it was there, and the midpoint of another class that is assumed to be there. So we assume that there was another class that it ends there. So in the same graph, we have drawn a frequency polygon and a histogram. Histogram are the bars, and the frequency polygon, it is the line I have drawn in black. Let's move on and see how it will behave. I think we have answered the 3 questions. Now I want to give you one question that you will try. Another question on statistics. Let us take trial 2, paper 1, question 20. So in that sequence, trial 2, paper 1, question 20. Well, I want you to do this one. I want to give you like 5 minutes to develop a frequency distribution table of interval 5, starting with the class 145 to 149. I'm waiting for somebody to give us the class. So you start. Oh, yes. Twende kazi. I believe you have tried. Somebody. Frequency distribution table, starting with the 145 plus interval 5, starting with 145 to 149. So we get our first class. I know this is what you have done. You are going to give me the values of frequency, the class, and then frequency. Our first class is 145 to 149. Next class will be 150 to 154, 155 to 159, 160 to 164. We have 165 to 169. We have 70s, 170 to 174. We have anything above 75. If it comes up, we will accommodate it. Well, now I want us to unmute, and we give suggestions of frequencies, and others will say yes or no. Let me pick one person. Eunice, give us your frequencies.
145 to 159. Frequency of 2. 150 to 154. Frequency of 1. 155 to 159. Frequency of 11. 160 to 164. Frequency of 4. 165 to 169. Frequency of 8. 170 to 174. Frequency of 7. And the last one, frequency of 3.
So this 175 to 179.
Yeah.
Well, Brenda, are you in agreement with Eunice?
Yes.
Good. So with that frequency distribution table, of course, there is one column that I have skipped, the column of tying, a process of coming up with the frequencies. Next question is, from the table above, calculate the mean mark. For the mean mark in form 2, in statistics 1, we need a column for x. A column for x, it's very easy. Column for x, 145 to 149. The sum of the two divided by 2, we get 147.5. So 147.5, 152 157.5, 157.5, 162.5, 167.5, 172.5, 177.5. Then you need another column for fx, frequency times the class midpoint, and then you need the, yes?
I'm saying in the X column, there won't be any 0.5, there won't be any decimal number, because when you add both the numbers from the class, it will give an even number.
Oh, there's no 0.5.
Yes.
Oh, it's my calculation which is wrong. Let me check. So it is 147. Good. 147 is a decimals years ago. 147, 162, 1. Well, yeah, understood. From this one we need fx, and then fx we find the sum of fx, and from the sum of fx, and we have the sum of frequency, of which this one is 36. Then we state the mean. Mean is equals to the sum of fx divided by the sum of f, and this one gives us somebody who has worked out, give us the numbers, the sum of x after multiplying, and then you find. Calculate a median. For the median, we said we need a cumulative frequency column. For cumulative frequency column, we need, it is 2, 3, 14, 18, 26.
33.
You have 33.
36.
And then 36. So what is the sum of fx? What wamefanya? Those who have multiplied, let us feed the information there. The sum fx 147 times 2. I don't want to leave it hanging. 147 times 2. 152 times 1, 152. Then you will find the sum.
147 times 2, 294.
294.
157 times 11, 1727. 162 times 4, 648. 167 times 8, 1336. 172 times 7, 1204. 177 times 3, 531.
The sum of fx. Maybe somebody has worked out. It's not about to wait for her. You can unmute and give us the figure. Yes, yes. We want also to calculate for the median. And the median, we said we need cumulative frequency first column. And then we state the formula for the median. Median is equals to lower class boundary of the median class plus n over 2 minus c over f times the interval. And we need to know the median class. 36 divided by 2, 18. We look for the number 18 or the number greater than, first number greater than 18. This is our median class. You circle it. Then from median class, we go and get the lower class boundary of the median class, which is 159.5. So we have 159.5 plus n over 2, 18, minus frequency, cumulative frequency above the median class, 14, minus 14, divided by the frequency of the median class, which is 4, and times the interval, 5. And this one gives us the median mark. Of course, I was waiting for the sum of fx. Somebody?
5892.
50?
892.
5892 divided by 36. So what is the mean?
$163.67.
0.67. That's the mean. And somebody who has worked out for 159.5 plus 18 minus 14 over 4. This one gives us 164.5. I see something like that. 164.5 as our median. 18 minus 14, 4 divided by 4, 1 times 5, 5, 159.5 plus 4 plus 5, 164.5. So this is the the mean and the median. Our next question is the draw a frequency polygon using the table in A. Frequency polygon. For frequency polygon, we know it is a graph of frequency against the class midpoints. That's a frequency polygon. It's a graph of frequency against class midpoints if the class interval is uniform. And in this case, the class interval is uniform. So we need the midpoints, which we have 160, 147, 152 as such. Then we need another class. I want us to be critical here. Which is the class with the same interval before 145? It will be 140 to 144. There is a class of that kind or that it had a frequency of 0, so it is not noticeable. And the last class is 175 to 179. So there is another class that has a frequency of 0, which is 180 to 184, but it has a frequency of 0. So we need those classes when we want to draw a frequency polygon. That's where we want to start from. But basically, a frequency polygon is a class of frequency against class midpoint if the class intervals are uniform. I want to give the condition if the class intervals are uniform. If they are not uniform, it is frequency density against the class midpoints. So our first class, our highest frequency is 11. So our numbers must accommodate 11. So we start with the 1. Let me start with the 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our frequency will go up to 12. Then our first midpoint is 147. So we start from 142. Then 147, 152, 157, 162, 167, 172, 177, and 182. So once we have now the midpoints, we plot. The first one is frequency is 2. So we need 2, 147, 2. 157, we have 1 and then 11. 157, 152, 1, 157, 11, 162, 4, 8, 152, 4, and 167, 8. We have 172, 3, 177, 3, 172, 7, and 3. 72, 7, 177, 3, and then is 0. So we join, we start from 142, we go there, end up, but we are using straight line. That is the frequency polygon. It's very easy when you know the modalities. What are you plotting against what? These are frequency polygon, but it must start from. Remember, we did not have this class. We made assumption that there was a class before the first class that had a frequency of 0. We never had this one. There's a class after the last class, but they had a frequency of 0. So our polygon will start from there. Then now we plot the other midpoints all through. So it is the class of frequency against the class midpoints. That's what we call frequency polygon. Histogram is a graph of frequency against upper class boundaries, starting with the lower class of the first class, lower class boundary of the first class. If the class interval is uniform. If not uniform, we go with the frequency density. That one marks the. I will give you another one you attempt, and then we. Let's go to trial paper 4, question 21. Disbehaving like it is the same thing. Hiyo tumefanya sana. Tutafute ingine. Hiyo ni ya form 4. Trial paper 720. Still it is a frequency polygon. I think we have really exhausted the same. Okay, let's see the ones with the lower marks. Try paper 1 equation. Try 1 equation 16. So that is what we do in statistics 1. Any question? Somebody ask a question on statistics 1? As we do the highlights of okay. Acha tufanye kitu inaitwa quartiles. Question 16. We highlight and do something on quartiles. Good. Beth, read the question. Question on the screen. Susan, read the question.
Determine the lower quartile, upper quartile, and the quartile deviation for the following set of numbers: 5, 10, 6, 5, 8, 7, 3, 2, 7, 8, 9.
Sawa. Determine the lower quartile, upper quartile, and the quartile deviation for the following data. We had quartiles. In statistics 2. Where we say the quartiles, it is dividing data into 4 equal parts. If we have this set of data, the first one we call it the midpoint, median, and it is actually Q2, the end of the second quartile. If we get the median of the first half, we get Q1, which is the lower quartile. If we get the median of the second half, it's called Q3, which is the upper quartile. So we are dividing data into 4 equal parts. But when it comes to ungrouped data, we have to be a little bit careful. we investigate and see the value of n. So what is required of us is to arrange this data in ascending order. I don't want to give the option of descending order. I want to give it as ascending order. So in ascending order, we have 2, 3, 2, 3, 5, 5. We have 6, 7, 7, 6, 7, 7, 8, 8, 9, and 10. So we have arranged this data in ascending order. Then we ask ourselves, what is n? N is the entry. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I say like it is 12. So I started to be corrected. Yes. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. The 11. Somebody to confirm? You have to be careful. I think it is 11. If the entry is odd, that's for ungrouped data. Q1 it is equals to n plus 1 divided by 4, which is 12 by 4, which is 3. So this is the position of Q3, Q1. So our Q1 will occupy the third position. Q3 it is equals to 3 into n plus 1 divided by 4. This is n plus 1 is 12 times 3, that's 6, divided by 4, 9. So the position we are going to have is that 6 by 4, which is 9. So 9 is the position of Q3. So we get back and circle, we count and circle. So the position 3 is occupied by 1, 2, 3, 5. So the lower quartile is 5. Position 9 is occupied by 4, 5, 6, 7, 8, 9. Occupied by 8. So the Q3 is 8. Now I want you to have that one properly. That when we are looking for the lower quartile and the entry is odd, we adopt Q1 as n plus 3, n plus 1 over 4. So we get 12 over 4. The position which will be holding number 3, it is the one that will give us the Q1. So this is the lower quartile, this is the upper quartile. Quartile deviation. Deviation. It is also called same interquartile range, which is always equals to the upper quartile Q3 minus Q1 divided by 2. So it is 8 minus 5 divided by 2, which gives us 1.5. So the upper quartile minus lower quartile divided by 2, it gives us the quartile deviation or semi-interquartile range in that matter. Anybody has a question in quartile deviation for ungrouped data? Let us see whether we can get another one, and then you try your paper. Trial paper 8, question 9. Let us see what it is saying. Trial 8, paper 1, question 9. Yes, exactly the same question. I want you to work out this one. Waiting for the answer. Yes, somebody raise up your hand and take us through the question. Somebody. Who's going to tell us what she has done from her side? I need one person. I will be your secretary. Jacinta, are you done? Jacinta is not talking. Candy, are you done?
Not yet.
Nancy, are you done? Daddy, are you done? Daddy, you are not talking. Shalom, are you done? Eunice, are you done?
Maybe a trial.
You try. Okay, trials are allowed. What is your first step?
1. 10 plus 1 over 4, which is 11 over 4 is equal to 2.75 Q1. Q3.
No,
3.
give me the steps. One, we are supposed to arrange the numbers in ascending order, sindio?
So nika arrange 2, 3, 4, 5, 6, 7, 8, 9, and 11.
You are too fast.
Sorry, 2, 3, tumefika kwa 5, 6, 7, 8, 9, 11.
11, Then we said number 2 is to assess to see and whether what is the value of n.
And the value of n is 10.
They are 10, Okay. Then once you know it is 10, the Q1. For even entry, we don't add 1. It is just position would be n over 4, which is 2.5. Sindio? Ulifanya hivyo?
Niliadd.
Uli add okay, 2.5. It is a position. I hear what you did. Then now you count 1, 2, 2.5. It must land here, which will be, now your Q1 will be equals to 3 plus 2 divided by 2, which is 2.5. Ifanya hivyo, Q3 will be 7.5, 10 divided by 4, 7.5.
Yes.
Times 3. 3 times 10 divided by 4, 30 by 4 is 7.5. So tutafute 7.5. 2, 3, 4, 5, 6, 7. 7.5, it lies in between there, which is 8 plus 7 divided by 2. And this one gives us 15 by 2, 7.5. Do you have that one, Eunice?
Yes.
Then now quartile deviation. Interquartile range. Tumesema quartile deviation is equals to Q3 minus Q1 divided by 2. 7.5 minus 2.5 divided by 2. This one gives us 2.5. Sawa sawa. Okay. That's all about the quartile deviations and the quartiles for ungrouped data. Others will come in along the way. This marks our last day of our discussion. I'm going to approach